Today's cosmic report brings attention to one of the most talked about space dates of the year, June 25th, 2026. Across observatories, satellites, and deep space monitoring systems, unusual patterns and surprising updates have drawn the interest of astronomers worldwide. What seemed like a routine day in space observation quickly turned into a moment filled with discovery, speculation, and deeper scientific curiosity. On this date, multiple space agencies recorded sudden shifts in high-energy cosmic radiation levels coming from distant regions of the universe. These spikes, while not dangerous to Earth, suggested that powerful astrophysical events may have occurred far beyond our galaxy. Scientists believe such activity could be linked to massive stellar explosions or previously untracked black hole interactions, releasing enormous energy into space. At the same time, several orbiting telescopes detected unusual light distortions in deep-field imaging. These distortions briefly affected the clarity of faraway galaxies, raising questions about gravitational influences or unknown cosmic structures passing through observational lines. While the data is still under review, early analysis suggests that space is far more dynamic and unpredictable than previously assumed. Closer to Earth's orbit, tracking systems also noted minor but noticeable variations in satellite communication signals. Engineers confirmed that the changes were temporary and caused no disruption. But the coincidence with deep space activity has led researchers to study possible connections. What makes June 25, 2026, especially significant is not a single event, but the combination of multiple anomalies occurring within the same time frame. It highlights how vast and active the universe truly is, constantly shifting in ways that modern science is still working to fully understand. On June 25, 2026, space observatories recorded unusual cosmic activity that attracted global scientific attention. On June 25, 2026, astronomers and space monitoring systems recorded an unusual surge of activity that immediately drew global attention. One of the most striking observations was a sudden increase in high-energy cosmic radiation arriving from deep space. These energy spikes were detected by multiple observatories at the same time, suggesting that the source was not a local or isolated event. Scientists are carefully analyzing whether this could be connected to massive stellar explosions, such as supernovae, or intense black hole interactions that release enormous bursts of energy across the universe. Although these radiation levels did not pose any threat to Earth, their unexpected intensity raised important questions about what might be happening in distant regions of the cosmos. In addition to radiation changes, space telescopes also reported brief distortions in the light coming from faraway galaxies. These distortions appeared as subtle warping or shifting in deep-field images, which could indicate gravitational influences from unseen massive objects or unknown cosmic structures passing between Earth and those galaxies. Researchers are still reviewing whether these anomalies are linked or purely coincidental, but the simultaneous nature of the events suggests a deeper cosmic pattern that is not yet fully understood. Sudden spikes in high-energy cosmic radiation were detected, possibly linked to powerful deep space events like stellar explosions or black hole interactions. Another major observation on June 25, 2026, came from orbiting telescopes that detected unusual fluctuations in deep space imaging data. These fluctuations were not part of normal background noise and appeared as temporary distortions in the light paths of extremely distant galaxies. Scientists believe this could be caused by gravitational lensing effects, where massive objects bend light as it travels across space. However, what makes this event unusual is the irregular and shifting pattern of the second distortions, which does not match typical lensing behavior caused by known galaxies or black holes. This has led researchers to consider the possibility of unknown or previously uncharted cosmic structures influencing the observations. At the same time, space agencies monitoring Earth's orbital environment reported minor irregularities in satellite communication signals. These were not severe enough to interrupt services, but they were noticeable across multiple systems simultaneously. Engineers quickly confirmed that the issue was temporary and likely linked to external cosmic conditions, rather than technical faults. The overlap between deep space optical anomalies and near-Earth signal variations has sparked further investigation into whether large-scale cosmic activity can indirectly influence space-based technology. While no immediate danger was identified, the event has encouraged scientists to re-examine how interconnected different layers of space activity may be. Orbiting. Telescopes observed temporary light distortions in distant galaxies, suggesting unknown gravitational effects or hidden cosmic structures. Alongside the radiation spikes and optical distortions, June 25, 2026, also revealed intriguing changes in the behavior of space-based communication and navigation systems. Several satellites operating in different orbital layers reported brief inconsistencies in signal timing and frequency stability. These variations were subtle, lasting only a short period, but they were recorded across multiple independent systems, which made the event scientifically significant. Engineers ruled out internal hardware malfunctions or software errors, suggesting that the cause may have originated from external space conditions. One possible explanation being explored is the influence of heightened cosmic radiation interacting with Earth's magnetosphere, which can sometimes affect electronic systems in orbit. However, the simultaneous occurrence of deep space anomalies has led researchers to consider more complex interconnections between distant cosmic activity and near-Earth space environments. During the same time frame, ground-based observatories also noted minor disturbances in radio wave clarity used for astronomical measurements. While these disturbances did not impact daily communication on Earth, they were enough to temporarily reduce the precision of some scientific readings. The combination of satellite signal fluctuations and observational interference has encouraged scientists to develop more sensitive monitoring techniques. Overall, these events highlight how even small changes in the space environment can ripple across multiple technological systems in unexpected ways. Minor variations were also noticed in satellite communication signals near Earth, though no serious disruption occurred. One of the most closely examined aspects of the June 25, 2026 space activity was the possible connection between deep space phenomena and near-Earth environmental changes. Researchers began comparing data from distant galaxy observations with readings from Earth's magnetosphere to see whether both were being influenced by a shared cosmic trigger. Early findings suggest that increased high-energy particle flow from deep space may have slightly disturbed the outer layers of Earth's magnetic field. While these disturbances were extremely weak, they were measurable by sensitive instruments aboard satellites and space stations. This has led scientists to revisit older theories about how interstellar energy bursts might interact with planetary magnetic systems over long distances. At the same time, advanced modeling simulations were run to test whether black hole activity or supernova remnants could produce wide-reaching effects that extend beyond their immediate regions. Interestingly, some models showed that under specific conditions, energy waves could travel vast cosmic distances and create subtle interference patterns. When encountering planetary magnetic fields, although no physical damage or visible effects occurred on Earth, the consistency of these readings across multiple instruments has made the event scientifically valuable. It highlights the importance of continuous monitoring and suggests that space weather may be influenced by far more distant and powerful cosmic sources than previously assumed. The combination of multiple simultaneous anomalies highlights that the universe is highly dynamic and still full of unexplained mysteries. The most important takeaway from the June 25, 2026 cosmic observations is not a single dramatic discovery, but the combination of multiple unusual events occurring at the same time across different regions of space. Scientists emphasize that the simultaneous detection of radiation spikes, light distortions, satellite signal variations, and minor magnetic fluctuations suggests that space is far more interconnected and active than previously understood. Instead of isolated incidents, researchers are now considering the possibility of large-scale cosmic activity influencing multiple systems at once, even across vast distances. This has opened new discussions in the scientific community about hidden energy networks in the universe, and the way massive cosmic events may send ripple effects through space. Although none of the recorded anomalies posed any direct threat to Earth, they have significantly contributed to ongoing studies in astrophysics and space weather prediction. Agencies around the world are now planning improved observation strategies using more sensitive instruments and coordinated global data sharing to better understand similar future occurrences. The event has also highlighted the importance of continuous deep space monitoring, as even subtle changes can provide valuable clues about the structure and behavior of the universe. Ultimately, June 25, 2026, stands as a reminder that the cosmos is constantly evolving, filled with complex and still unexplained phenomena waiting to be discovered.